Hey robot fans, welcome back to the build. Today we are going to do all of the electronics for the helmet. It's going to be a long one, but fun will be had, secrets will be revealed, so let's get started. Okay, first up we have the ROM FX module from John May. This will give me an amplified voice along with some pretty cool voice effects. Out of the box it looks like this. You have the ROM FX board, a speaker, a microphone, and a power supply. Now, I don't think we're going to be using this power supply. Right now I'm using a dedicated DC power supply, and in the helmet it'll have its own set of batteries, so we can just get rid of this for now. Now the kit comes with this speaker. If we test it out,
Testing, check 1, 2.
you can hear it's very loud, but that's also because it's pretty big. I don't think I'm going to be able to fit this in the helmet the way I want to. What a lot of builders do is they'll put it in their chest plate and then run a wire from their head down to their chest. I don't want to do that in any way. I want to keep this helmet 100% self-contained, so I don't think we're going to be able to use these speakers. Instead, we're going to be using these much smaller 5-watt 8-ohm speakers wired in parallel. They fit really nicely behind the hollow greeblies we made back in part 4. I printed a little enclosure for them, which gives the front a little more surface area to glue down to the helmet, and also gives me the opportunity to insulate the sound a little bit with some foam. I printed this little mic stand here. This holds the mic in the desired configuration while giving me a flat surface to put some Velcro tape onto. Velcro tape will be the main method of sticking everything inside of the helmet due to its non-permanent strength. Feedback is a bit of a concern with this system. If any of the sound from the speakers makes its way back into the microphone, well, that won't be good.
Test, checking 1, 2. Okay, it works. That's good. There's no feedback happening right now, and if it's not feeding back right now, it's probably not going to feed back because there's only going to be more padding and more stuff inside the helmet to absorb all the sound. So if it's okay right now with all this bouncing around, we should be good. Those bursts, that's not feedback, that's actually the ROM effects. Every time I stop talking, it gives me a static burst. Yep, so let's move on to the next system.
Now, I also want to be able to hear what's going on around me while I'm wearing my helmet. I don't want any clankers sneaking up on me, so I'm going to install an external amplified relay system, or simply ears. Remember all my secret holes from part 5? Well, those are to house the cornerstone of the ears system, these little microphones. They are really tiny and they just so happen to fit right into that little recess under the ear. I paid extra special attention to this area during the weathering process so that I can get it as dark as possible so the microphones would be as invisible as they can possibly be. These mics will replace the slightly larger Electret microphone on this prefab amplifier board, and the whole thing will glue onto the inside of the helmet with the microphone pointing through the hole. For the speaker, we will be using these very tiny, very thin 2-watt 8-ohm speakers. I printed a little housing for them with a mesh glued on top, essentially turning them into a headphone. This will be housed inside of a piece of padding from the helmet padding kit we'll be seeing more of later. I put the connections from the amplifier to the speaker on these little DuPont connectors so I can still detach the ear as necessary for maintenance. These last 2 ports connect to 5 volts and ground, which will give us a full mono sound system on each ear. From what I hear, cooling fans are crucial to the trooping game, so I'm going to install these 2 thin line blower style fans just above my forehead. They are 12-volt DC fans, and in interest of saving some power and adding a little extra comfort, I'm wiring these fans up to a transistor so I can use an Arduino to give them some speed control or just turn them off completely if I want to. These are velcroed into place with some extra slack in the wiring so I can find that sweet spot for optimal cooling and defogging. Speaking of the Arduino, it's also going to be controlling our lighting system. One of my favorite sci-fi tropes is the interior helmet lights that serve no purpose and slightly blind the character, but we could see the actor's pretty face. We paid millions of dollars to get Matt Damon in this movie, and damn it, we're going to see his face. Well, yeah, I want that in my helmet too, so I'm going to install 2 NeoPixels on each one of the cheeks, and since they are individually programmed NeoPixels, I can have a lot of fun with this lighting. It'll probably only be on 1% of the time, if ever, but that 1% of the time is going to be pretty cool. Now, all of these electronics are going to need some power, so let's talk batteries. After trying out a few different types of batteries and weighing safety concerns with battery sizes and capacities, I decided to use these nickel metal hydride packs. These little 6-volt battery packs are essentially 5 AA batteries wired in series. I'm going to wire 2 pairs of these in series to give me 12 volts, and then wire those 2 pairs into parallel to combine the lifespan of the 2 packs. Finally, I velcroed the packs into place on top of the helmet and sat back to admire all of my wonderful electronics, and oh boy. Piecemealing all this together has made things a bit messy in the back of the helmet here. It still fits and everything is connected properly, but yeah, I can't leave it like this. There is no way these wires aren't going to get pulled out or sweat on or whatever through the life of the helmet. So I think that everything is now in place and I have a firm idea of what's going where. I need to consolidate a lot of this onto some proper circuit boards. Luckily, I have a few of these Proto Boards on hand. These are different than the ones I usually use in that there are defined strips on the back which can be used to create power buses. This will eliminate the need for those wago nuts and a lot of the wiring. Here's my sketch of the Proto Boards before I start wiring. It looks super complicated, but it's really not. The wiring is super tight and tricky, but these two boards will literally replace everything in this mess. I decided to color the board black, so when all is said and done, it'll be hidden a little nicer on the back of the helmet. Wiring everything up was a breeze, and before I put them back in the helmet, I can give you a rundown of how this all works. Power is going to come in from the batteries to this toggle switch here. This will be the main hardware switch for the entire helmet. From there it goes to this buck converter. I have 12 volts coming in, and this board will step that down to 9 volts and charge this whole rail with the 9 volts. These 9 volts will power the ROMFX voice module and output over to the Arduino on the other board. Up top, I have a rail dedicated to the ears systems. They are going to be controlled directly by the Arduino pinouts and will use this bus to transfer power over to the other side of the helmet. And this board also handles my transistors for the ROMFX voice module and the fans. A transistor is basically a switch controlled by a small current. The transistor breaks the power circuit to the fans on the ground side, and only after receiving a small current from the Arduino will it complete the circuit. This gives me an on and off switch for the ROMFX and the fans controlled by the Arduino. I can also use this for speed control on the fans using a PWM signal. I can quickly turn the fans on and off about 50 times per second, and if over any given second the fan is on for 50% of the time, that would translate to about 50% output from the fan. This will essentially give me an off, low, and high setting for the fans. From this board, a few data cables for the ROMFX and fans, a 9 volt and ground wire transfer over to the second board through this 5 volt step down, which will then power this 5 volt rail. The 9 volts from the first board will power the Arduino through the VIN pin, and the 5 volt step down will power our lights and communication. Finally, we have all of our Arduino pinouts here, which will go to each component in the helmet, and all of this is communicated through this Bluetooth module. Inside the helmet, I also printed a cover for that back panel with lines much straighter than my Dremel cuts back in video 3. I was hoping to attach some outblowing fans here, but with the fans on top of this grill, my head no longer fits inside, so it'll just be the cover. So this is the part of the video where I get to do one of those makeover show style reveals. So with a flourish, we can reveal our new back of the helmet setup. Yes, this is much better on every single level. There is less wires, less mass. The voltage readings are better throughout the whole system. And even better yet, I can cover most of these boards with some felt tape since heat isn't really an issue except for on the Arduino and the buck converters. And that will only make these even more hidden and more cohesive inside of the helmet. Now, I keep talking about Arduinos controlling things and adjusting fan speeds, so how am I going to do that when the helmet is on my head? Well, each clone is fitted with his own COM pad on his right forearm. Usually this piece is just a greebly and has no real function, but I plan on using mine as a keyboard to input commands to the Arduino in the helmet. The COM pad itself will be built in a future episode, but for now I've built this super sexy temporary breadboard version. It has an Arduino Nano, which is very small, but in the actual forearm I'm going to use the even smaller Arduino Pro Mini. I have 6 buttons set up here for now, and all this runs through the Bluetooth, which sends the commands to the Arduino in the helmet. Okay, we're ready to test this out. We have our COM pad here with the Bluetooth module. If we were to look inside the helmet right now, you would see that the Arduino is on and the Bluetooth module is blinking very quickly. That means it is looking for its partner, which is sitting right here on the COM pad. When we plug power into the COM pad, we will see this LED come on when the Bluetooth modules are paired. So we're waiting for this light here. Okay, now that the light is on, we know that the two items are paired and we can start sending communication from this Arduino to the Arduino in the head. So we could start with the ROMFX since we can hear that right away. If I press the ROMFX button, we hear the ROMFX come on inside the helmet. Can also test out the lights. We hit the helmet light button, we should see those blue lights come on. Very good. I also set up a disco button. This is going to be my special lighting effect. For right now, all I could think to do was add some crazy seizure-inducing disco lights. So those will flash like that. That should be a lot of fun to wear. And lastly, we can test out the fans. I'm not sure if you can hear this, so I will put my microphone inside the helmet. And now if I press the fan button, you can hear the fans going. Turn the fans off. And yeah, so this works. I couldn't think of any reasonable way to show you how the ear system works, so you'll just have to take my word for it. Now let's finally get this helmet fitting on my head properly. I bought this helmet padding system from Amazon, and along with the rest of my Velcro taped pieces, I strategically placed these pads all around the helmet so the fit is snug and my eyes are properly aligned with the visor. And as is becoming tradition in these videos, the absolute last step is to reinstall my macro binoculars, put those ear greeblies back on, and get ready to wear my fully self-contained electric clone trooper helmet for the first time.
Oh, that sucks.
Disco.
Alright, that's gonna do it for this video. Thanks for tuning in. I think we got everything working the way we wanted to. Here, let me turn on my helmet light so you can see me a little better. There we go. I'm very happy to say that we are finally going to be moving on to the armor. The first video of that is going to be the arms, which will lead into the comm pad, which controls the helmet, of course. If you like these videos, please take the time to subscribe. Check out some of my other projects. As always, we're going to finish with the progression shot, so I will see you next time.
Disco.